Here we go. Very similar format to your in-class exams. It will be multiple choice. Yes, you will get a formula sheet at the very end of this document. Okay, so you will get a formula sheet. You'll also get the table for Z-scores. Okay, we'll provide that for you. Okay, Crystal algorithm. Find the weight of the minimal spanning tree. Okay, this goes all the way back to exam 1. All right, first thing we need to do, if we're going to find the minimal spanning tree, we need to list all of our weights in order from smallest to largest, because we want the minimal. So we've got a bunch of ones. 1, 2, 3, 4, 5 ones. We've got 1. And then the next one up would be a 2. So here's a 2 and another 2. So 2 2s. And then 3s. One up top, another one right there. So 2 3s. And then let's see, we've got a 4. And I believe 2 5s. And then a 7. And then an 8 and 11. Stay with me? Okay. Now, to find the minimal spanning tree, we have to select, you want to start with all of the small edges. Now, these are all going to be random at first. But the key thing is, since it's a tree, you do not want to make anyone remember?
Circuit.
Don't make a circuit. All right. So let's choose some of these ones. So we can take that one right there, and that one right here. Let's see, this one, 1, 2, 3. That one down the side. I feel like we're missing another 1 somewhere. And this one down here. Right? So far, no circuits. But we don't have a tree yet. We haven't covered all of our vertices. So those are done. Next up, let's look at the 2s. Well, the 2 on the far left, that's fair game. Right? And we've got another 2 over here in the middle on the bottom. That one's fair game as well. We haven't created any circuits. Okay, so those are done. Now for the 3s, let's see. We can't use this 3 in the middle because that will create a circuit. Can we use the 3 up top?
Yes.
Sure. Have we covered all of our vertices? Yes. So we've covered all of our vertices. See all of the numbers that we used? Add those up. So we need 5, 4, and 3. So that's what 9 plus 3 gives us 12. First one's A. Everyone remembering some of this? All right, next up. 2 marbles are drawn without replacement. There's keywords there. From a box with 5 white, 2 green, 2 red, and 3 blue marbles. Find the probability that the first is blue and the second is blue. Now, key thing to remember, if you are drawing marbles out of a box or a jar without replacement, what happens to your sample space? It changes. Okay, if we do this without replacement, your sample space changes. Okay, so first draw. What's the probability of drawing a blue marble? Well, total we've got, let's see, 5, 2, 2, and 3, so we've got 12 total. Okay. What's the probability on your first draw? How many blue marbles are there? 3 out of a total of 12 times your second draw. Well, if you already pulled out a blue marble, how many blue marbles are left? 2 blue marbles are left, and again, without replacement, what's the size of your sample space? 11. together. Three out of 12 times 2 out of 11. 1 out of 22. You can use your calculator for that one. Okay. Anybody still writing this? Because this writing will disappear in order for me to scroll down. So speak now, forever hold your peace. Okay. Down the page. Number 3, the top 5 NBA scores of all time, listed along with the overall points scored. What is the mean number of points scored? Okay, if we're talking about the mean, what is that? Regular old average. Bust out your handy dandy calculator. And we've got 38387 plus 36928 plus 32292. Are we clear on where these numbers are coming from? Okay. Plus 31617 plus 31419. That gave me, let's see, I've got 170643. After you add everything up, we divide this by 5. I've got 34128.6. How about A? How are we doing? Yes, no, maybe so? Adjacent vertices. What does it mean if your vertices are adjacent? They're connected by an edge. Is the key word there. All right, so we're looking at what is adjacent to vertex B. Then there's B. Okay. And look at all of the edges that come off of vertex B. So there's one, there's one, there's one, and there's one. So we've got vertex A, G, E, and C. How about that? I think that's an error in the answer. Nope, we're good. Never mind. I'm looking at the wrong number. Questions? Again, if you're writing, better say something now because the writing will disappear. Come up here. Down the page. Number 5. Suppose that the generator matrix for a 4-8 code is as follows. Find the code word corresponding to 1010. Okay, so we have the generator matrix, we have the code word, you got to punch it into the generator matrix to find out the new encoded word for transmission. So to do this, we write the number vertically down the side, 1010, and we only look at the rows that correspond to what number? 1 in the original message. So we're going to cross out the second row, cross out the third row. From here, what do we do?
Add them down.
Add top to bottom. So the first column, 1 plus 0 is 1. 0 plus 0 is 0. 0 is 1. 0 and 0 goes to another 0. How about 1? A 0. 1 plus 1 is 0. 0 and 0. Let's see. 1, 0, 1. 0, 1. 0, 0, 0. How about D? Yeah. Miss Salita takes out a conventional installment loan for 5 years at 6.1% compounded monthly. What are her monthly payments if she borrows $10,000? All right, so for this one, we need to go to our handy-dandy formula sheet or go to your lecture notes. She's taking out a loan for 5 years. We need to find out what her monthly payment is. This is that really ugly formula on page 75 of your lecture notes. And bust those out, page 75. So we're looking at P times 1 plus R over N to the NT is equal to D, that's your monthly payment that we got to find, times plus. Our interest rate was 6.1%, so as a decimal, you must rewrite that as 0.061. If we are compounding monthly, n is equal to 12 to the 12 times how much time are we keeping this loan? So 5 on top is equal to your deposit amount. Again, that's what we're solving for. Times same quantity from the left side of the equal side. 1 plus 0.061 over 12 to the power of 12 times 5 minus 1 divided by 0.061 over 12. All right, that's just plugging in. Haven't done anything fancy yet. Now, again, we're going to start by finding this piece right here. Same thing on both sides. So on your calculator, notice the parentheses, okay? The other thing you need to know, make sure you put this piece in parentheses as well. Put your exponent in parentheses. So here's the buttons you push, piece by piece. Parentheses, 1 plus, put another set of parentheses over here, around r over n, 0.061 divided by 12, close parentheses. Close parentheses again, because you're raising that whole chunk. Then hit your caret. Open another set of parentheses and hit 12 times 5. Close that set of parentheses. So that piece alone, we've got 10,000 times. I've got 1.355577291 is equal to D times. Okay, now that block in red on the right side of the equal sign, that's the same thing we had on the left side, right? You should still have that number on your calculator. So across the top, you can go ahead and hit minus 1. So subtracting 1, you should have just the decimal, 0.355577291. So 0.355577291, and then we divide all of that. Now watch this. Parentheses 0.061 over 12. So you, on your calculator, you should still have the 0.355577291. Hit divided by, open parentheses, 0.061 divided by 12. Close parentheses. The new right side of your equal sign should be D times, we just did that stuff in the brackets. That's 69.94963,105. Okay. One more, well, 2 more steps technically. Go back to the left side and multiply that times 10,000. So 10,000 times our 1.355577291. And you should get 13555.77291. And then we're going to take that number and we divide it by this guy. 69.94963,105.
I got 106 on that. On this over there, I got 106.
As your final answer?
Yeah.
Because I got the 193.79.
No, I mean, I don't know how much it matters, but I was following you along, and I got 69.94963,106.
Oh, that's just because it rounds off at the end. That when the decimal is that far out, it usually won't make that much of a difference if we're talking about way farther on the left side of the decimal. Okay. So, if you were having trouble with this formula, I very, very strongly recommend that you go back and rework some of the problems. Homework, notes, you now got another one, and there's also review questions in your lecture notes. Question?
Every time I do this side of the calculation?
Left side or right side? I can't tell which side you're pointing at. Your left or your right?
My right.
Your right, okay.
Okay. Every time I do that formula, like, plug it in my calculator, it doesn't turn out right. And that's every time I do it.
We'll chat.
Okay.
We'll have to chat about that. Okay. Other questions regarding this formula? Okay, I see a lot of pencils still moving, so I'll give you a second. I'm assuming that means you're still writing for this one.
Scratch paper.
You can write on that. Yeah, and remember you get the formula sheets, you can always write on that formula sheet too.
Do we get to keep our test?
I'm not sure for the final. I'll have to talk to the department about that. I'm assuming no, just because in all the other classes I've taught, they don't get to keep their finals.
Okay.
Anybody else still writing? Remember, this will disappear. Writing will go away. We're good? Moving on. All right. Given this histogram, which statement is true? Well, is it skewed to the left? Does that mean that you have a lot of outliers on the left side? Okay, remember, this one is weird. When you're talking about skewed left or right, it's opposite of what you originally think.
Yeah.
Well, the outliers aren't on the far left. All the outliers are more towards the right. That means that this is more than likely skewed right. But let's look at the other options. Is it bimodal? Well, bi meaning two. Modal, does it have two modes? Does it have two really big bumps in it? No. It's just got one giant one right over here on the left. Is it symmetric? Nope. Is the mean equal to the median? This graph doesn't really tell us too much about that. So, best answer here, this graph is skewed to the right. Your outliers are towards the right side of the graph. You've got more numbers hanging out this way, where you've got the majority over here on the left side. Opposite of what you think it is. Number 8, which of the following graphs have an Euler circuit? Okay, to have an Euler circuit, well, first of all, are you looking at edges or vertices? We're looking at edges. Okay, put your E's together. If you have Euler, you're always looking at edges. To have an Euler circuit, what's the rule about the vertices? They all have to be
Connected.
Odd. Even.
even. Euler circuit, even vertices. Put the E's together. Okay, if you're doing Euler circuit, even vertices. If you're doing an Euler path, that's the one where you have to have only two odd vertices. Euler paths are the weird ones with the odd vertices. Okay? So, take a look at your graphs. Which graphs have only even vertices? We know graph 1 does, for sure. How about G2? Second graph? Nope. Look at all your corners on graph 2. They're all odd. And graph 3, you can look at vertex A. That one's odd. It's already out of the game. So, number 8, the answer should be A, G1 only. Can you explain how it's A? Okay, look at the vertices. Count the number of lines coming out of each vertex. You want every vertex to only have even edges coming out of it. So if you look at G2, look at vertex A. How many lines are coming off of vertex A? It's odd, so it won't work. Same thing in G3. If you find just one vertex that's odd, it's out. No Euler circuit. Graph 1 is the only one that has all even vertices. All even. That's a good thing. Number 9, the number of edges in a tree with 18 vertices is? It's just one less. If you're talking about a tree, it's one less than the number of vertices. Okay. Questions on 7, 8, or 9? Anybody writing? Next page. Number 10, Miss Whitney borrows $1,000 at 5.5% simple interest. There's your key word there, simple interest, for what formula you'll probably be using. What is the total amount due at the end of 4 years? All right, let's take a look. We're talking about simple interest. So, find the page for you. Okay. We're looking at page 67 of your lecture notes. Make a note to yourself if you need to. And, let's see, she's borrowing $1,000, simple interest for 4 years. So this is the same as what we would call the future value. To find the future value, your accumulated amount is equal to your principal plus the amount of interest earned on the principal amount. So that's going to be P times R times T. Remember, this piece right here is interest. Simple interest. Plugging in. Our accumulated value is equal to a principal amount of $1,000 plus the interest earned on your $1,000. Okay, so 1,000 was our principal. Our interest rate, 5.5%, write that as a decimal, 0.05. And time is always given in years, so be careful here. If this were 4 months, you would write this as 4 out of 12, so 4 divided by 12. Since we're talking about 4 years, you can just plug in a 4. And punch it in your calculator. So 1,000 plus 1,000 times 0.05 times 4. I've got, let's see,
1,200.
Yes, it is. Thank you. Fix that on my calculator too. Okay. How about A? 12 Questions?
Okay, this doesn't have to do with the problem, but on page 65, there's a formula, compound interest.
Page 65?
Yes.
Okay.
Continues with A equals PE to the RT.
Say it louder for me.
The formula compound interest continues. A equals PE to the RT. That was on the last exam at the bottom of the page.
Let's see. Why do I have no page 65 here? At the bottom of the page, compound interest continuous, okay?
Yeah, that was on the last exam, but we wasn't taught how to like do that formula.
We did. We did one. We did one in class. You just have to use that special button E on your calculator.
I don't remember.
Or it tells you on the formula, E is approximately 2.71828, and then you hit the caret, and then punch in the RT.
Okay.
Yeah. Okay. Number 11, nearest neighbor tour, okay, or the nearest neighbor algorithm. Now the thing about this one, with nearest neighbor, you always have a starting position. This one we give you starting position. For something like cheapest link, there is no starting position for cheapest link. Okay. So we're going to start at vertex A, so we're starting here. All right, now you got to read this graph very carefully. If we're doing nearest neighbor, the next path you should take should literally be just that, the nearest neighbor. Well, we have a vertex that is, let's see, 17 away, another one is 14 away. Now if you read This diagonal going down and to the right, that one is 2, and then the diagonal going down and to the left is 11. You should probably take the 2. And we go to vertex C. So let's write this out. A to C. Okay. From C, again, do the same thing. Find the nearest neighbor from C. You've got a 9 going towards B. You've got an 8 going back towards vertex E, and a 15 going back to B. You should go to E. That gives us 8. It's not 8. How about I write the actual letter? 7. Okay. Now, from E, well, we can't go back to A because we haven't covered all of our vertices. That leaves either going to vertex D with a length of 12, or we go all the way to vertex B with a length of 16. Go to D. All right, we've got one more vertex to hit. So let's go ahead and go to B. And of course, remember, you got to come back to where you started. We have to go all the way back to A. All right, let's see which one matches. A, C, E, D, B, A. That would be letter D. Questions on nearest neighbor? Okay. Okay, next up. Find the median. What's the first thing you have to do when you're finding the median?
Put it in order.
Put it in order. All right, so let's rewrite this. Our smallest values are 16s, so 16 and 16. Next one up would be the 30, then 40, 48, and 95. Okay, if we're doing the median, that means you're finding the number directly in the middle. Well, here's the problem. We have an even number of numbers. If that happens, what do?
Divide the 2 middle.
Take the 2 middle numbers and take the
Sum divided by 2.
take the mean. Yeah. So 30 plus 40 divided by 2 should give you 35. How are we doing so far? Next up. First 9 digits of an ISBN are as follows. By the way, is anyone writing so I can scroll down? No, we are still writing. Okay. Number 13. The ISBN stuff was on page 53 of your lecture notes. So remember, you could have an ISBN question, like we're about to do. There's the FedEx tracking numbers, and then there's also the UPC code. So there are 3 possibilities. Make sure you can do all 3 algorithms. All right, key things about ISBN. Well, not the sum. Once you do 10 times the first digit, 9 times the second digit, so on and so forth, this has to be equal to 0. Mod 11. Meaning, your final sum has to be a multiple of 11. Here's how we do the setup. We got to number this. 10, 9, 8, 7, 6, 5, 4, 3, and 2. Okay, so I'm alternating so there's enough room. We take 10 times the first digit, so 10 times 1, plus 9 times the second digit, which is 2, 8 times the next digit, 1, 7 times 3, 6 times 0, 5 times 1, 4 times 2, 3 times 8, and 2 times 2. All right, punch that into your calculator. 10 times 1 plus 9 times 2, 8 times 1, 7 times 3, 6 times 0, 1, 2, 3 times 8, and 2 times 2. I got sum of 108. Okay, now we have to look at multiples of 11. Well, if you do 11 times 10, that's 110. That's the next closest one. If you do 11 times 9, it's too far down. Okay. So to turn 108 into 110, you have to add 2. So 108 plus 2 is equal to 110. So that is your check digit. Okay. Are we in agreement or did we miss something? We good? Because I'm looking at the key over here and it's saying something different. So if you do have discrepancy with what I wrote down, tell me. Yeah?
I got 98 right.
You got which one?
98.
For some.
You got 98? Okay, I'm going to go back through it. Because I wrote my numbers down wrong. I wrote 10 times 1 in the calculator, I hit 10 times 2. My bad. So yes, 98. That's why I asked. Thank you. Okay. So if 98 is our value, we have to use 11 times 9 equals 99. So we would do 98 plus 1 equals 99. There we go. So the correct answer should be A. Whew. Yes? Okay. All right. Determine the number of Hamiltonian circuits in a complete graph with 6 vertices. All right, we got to go all the way back to graph theory. Let's find us a formula. We started talking about Hamiltonians. Someone have page number?
12.
Page 12. Okay. See, find the number of circuits. We know it has to be a complete graph. So, we should take 1 less than the number of vertices. So if we have 6 vertices, we should take 5, and then do 5. Remember? Term is? Say it louder. Factorial. Close. Factorial. So if you have 6 vertices, take 6 minus 1. Factorial. 4 times 3 times 2 times 1. I've got 120. Okay. Remember that one? Factorial, you take the number times all of the numbers that come before it. Seems we can get halfway through this today, which means we need to get all the way through question 20. I think we're doing good so far. Find the probability that a randomly selected student prefers veggie pizza given that the student is a junior. Okay, so if we say, you see that keyword given, that means you're doing what kind of probability? Anyone remember? On page 30 of your lecture notes. Conditional probability. And that formula. So the probability of event B given event A happens first is the probability of A and B happening, remember you flip them, divided by the probability that A happens. Okay, so find probability that a student prefers veggie pizza given that the student is a junior. So we want the probability of veggie given a junior. Okay? So, probability that a student likes, or a student is a junior and likes veggie pizza, divided by the probability that the student is a junior. Still with me? All I'm doing is rewrite the formula according to the letters that we're talking about. Alright, so let's go to our chart. Find the juniors who like veggie pizza. How many are there? 23. Divided by, how many juniors are there? On your calculator, 25. Plus 10, plus 23, what do we get? 58. 23 out of 58. Okay. Anybody still writing? You good? Down the page. Number 16, perform the indicated calculation in Z9. So we're dividing everything by 9. Modular arithmetic. The only thing we look at is the remainder. Okay, so let's go ahead and do 8 plus 6. So, 8 plus 6 gives us 14. Since we're doing this in Z9, step 2 would be 14 divided by 9. Well, how many times does 9 go to 14? Once. Bring down the 9, subtract it, you're left over with 5. So this is 1, remainder 5. So this is part of congruence class 5. Okay, modular arithmetic, you only look at the remainder when you divide by your base. We're in base 9. Okay. 17, an optimal Eulerization of this graph can be obtained by duplicating how many edges. Now the key thing is you want to only duplicate the fewest number of edges possible. We want to Eulerize this graph. We want to force it to have an Euler circuit. And we just talked about this. To have an Euler circuit, every vertex must be even. Okay, well, let's take a look. That's an odd vertex, and that's an odd vertex. Everything else is even. 2, 4, 2. We're good. So you only have to repeat one edge. when you are Eulerizing the graph, the edge that you repeat must already exist. So if there were no line between those two bottom ones, you would have to go like around. That was a weird one. You can only repeat edges that already exist. Okay. Find the standard deviation of those numbers. What's the first thing you have to do when you calculate standard deviation? Find the mean, so find x bar, the mean. So we take, on your calculators, 9 plus 2 plus 5 plus 4 plus 12, okay, plus 7. And we divide that by 6. See, 9, 2, 5, 4, 7 times 6. I've got a mean of 6.5. Still with me? Okay. Step 2. You take your value, x, those are all the numbers from the chart, minus x bar. So the first one, we do 9 minus 6.5. And you get 2.5. And then we do 2 minus 6.5. And you get a negative 4.5. 5 minus 6.5. Thank you. Well, gives us a negative 1.5. Keep going down the line. 4 minus 6.5 gives us a negative 2.5. Let's see. 12 minus 6.5 gives us a positive 5.5. And then the last one, let's see, 7 minus 6.5 gives us 0.5. That's step 2. The next thing we have to do, we have to take each of these values, x minus x bar, and square it. So down the line, 2.5 squared gives us 6.25. Negative 4.5 squared gives us 20.25. All of these values in step 3 should be positive, by the way. They should all be positive. Negative 1.5 squared gives us 2.25. Negative 2.5 squared gives us another 6.25. 5.5 squared, 30.25. And then last but not least, 0.5 squared gives us 0.25. Add those up. 6.25 plus 0.25 plus 2.25 plus 6.25 plus 30.25 plus 0.25. We take 65.5 divided by 1 less than our numbers here. So we had 6 numbers, we divide that by 5, and we take the square root. I've got 3.62. The answer is E. All right, so there are 40 questions on this final. As you can see, we kind of ran out of time to get happy. I strongly recommend that for Friday you go through this and have questions ready, because obviously you won't have time to go through the rest of it. Don't forget the attendance.